Number 61. Which of the following represents the least number of molecules? And then I see A through E. I'm going to, think of this as a multiple choice question because they want to know which one out of the 5 have the least number of molecules. So the easiest way to go about this is you just got to find the number of molecules for each and then just pick the least one. So let's get down to it. So for A, they told us that we had 20.0 grams of H2O, and then they give me a number here. Now, every time that you see a gram per mole amount, that's automatically a molar mass, all right? So if it's in gram per mole, that's a molar mass. And for each one of these, they all give the molar mass, mm. So we don't have to find anything on the periodic table, thank goodness. We don't want to do extra work, so let's get down to it. Now I'm going to say that this one is A, and for each one, we have to start with grams because that's what they gave us for A through E. So we have to go from grams of a compound and try to get to molecules of that compound, right? What is the middle guy? Can we go from grams to molecules in one shot? Not really, right? What would we have to do first? We would have to go to moles. So it's always grams to moles to molecules of a compound, and then you can go to the molecules. So always remember that progression for an individual compound or an element, but it has to be the same. It's always grams to moles to molecules, all right? Or atoms, depending on whether you have a compound or a element. But anyway, let's get started. 20.0 grams of H2O. Well, I gotta get to moles first because this is the two-step process, 1 and 2. So, grams of H2O on the bottom, mole of H2O up top. Now, this is where the molar mass comes in. This is where you would actually look on the periodic table and figure out what the molar mass is. But they gave it to you, right? So remember, if you're reading this, I'm going to put it over here. 18.02 grams per 1 mole, right? If it's just per something, it's always per 1 if there's no number there. So that would be 1 mole for H2O, and the 18.02 would actually go on the bottom. Grams of H2O cancel out, and now we just have to convert to molecules, right? So times by the ratio, mole of H2O on the bottom, molecule of H2O up top. And what's the consensus between molecules and moles? That's super important. You guys should know this by now, right? 1 mole of anything equals Avogadro's number. So 6.022 times 10 to the 23rd molecules of that compound. And I say X because it could literally be any compound. So 1 mole of H2O is 6.022 times 10 to the 23rd molecules of H2O. So cross that off. And now we have the answer for A. So if I just do this in one shot, 20 divided by 18.02 times 6.022 times 10 to the 23rd. We need 3 sig figs because that's what we started here. So your answer should be 6.68 times 10 to the 23rd molecules of H2O. All right, so this one, 6.68 times 10 to the 23rd molecules. I'll put MOL. I might as well just write the whole thing. Okay. B, we do the same exact thing. So 77.0 grams of CH4, grams of CH4 on the bottom, mole of CH4 up top. They gave us the molar mass. So 1 mole equals 16.06 grams. Cancel out the grams. And now we just got to get to molecules. 1 mole of CH4. And then 6.022 times 10 to the 23rd molecules of CH4 up on the top. Let me just extend that. So the moles will go away, and now we can get the number. So 77 divided by 16.06 times 6.022 times 10 to the 23rd. We get 3 sig figs, because we still need 3 sig figs. So it'd be 2.89 times 10 to the 24th molecules of CH4. Now, since they want the least number, this number is greater than the molecules of H2O because 24 is greater than 23. So we can automatically cancel out B. Next one, C. 68.0 grams of CaH2 times, by that ratio, grams of CaH2 on the bottom, mole of CaH2 up on the top. They gave us the molar mass, so 1 mole equals 42.09 grams. And now, we don't want moles anymore, so that goes on the bottom. Mole of CaH2 on the bottom. Molecules of CaH2 up on the top. And then Avogadro's number, 1 mole equals the 6.022 times 10 to the 23rd. Cancel out moles, and now we have those molecules. So 68 divided by 42.09 times 6.022 times 10 to the 23rd. We still need 3 sig figs. So 9.73 times 10 to the 23rd molecules of CaH2. So this one we said already before was out, right? So let's just look between A and C. We still want the least number. They have the same exponent, but this 6.68 is less than 9.73. So A would still be in the running, right? C would be out because that's greater out of the two of them. So now let me just erase. Now I'm going to keep A there because that one's still in the running for the least number. I'm just going to get rid of all of these, and then we will jump into D. So how are you guys doing? Hopefully this is easy for you. Let me know in the comments what you think. Love to hear from you guys. D. 100.0 grams of N2O. Okay, well, times by that ratio, right? Grams of N2O on the bottom, mole of N2O up on the top. They gave me the molar mass. So, 1 mole equals 44.02. That's coming from this, right? Cancel out the grams. We're left with moles, but we got to make that ratio. Mole of N2O on the bottom, molecules of N2O up on the top. Avogadro's number, so 1 mole equals 6.022 times 10 to the 23rd. Molecules of N2O cancel, and we're left with moles of N2O cancel. Molecules is what we have left. So 100 divided by 44.02 times 6.022 times 10 to the 23rd. And now this one, we need 4 sig figs because that's what they gave us here. If you guys aren't familiar with sig figs and you want more practice, go back to chapter 1 for our playlist. There's tons of questions there. But this would be 1.368 times 10 to the 24th molecules of N2O. And I look at the exponents first. 23 is less than 24. So that means that this one would have to be a greater number of molecules. So D's out. Now we just got to see who's going to be the winner between A and E. So for E, there's 84.0 grams of HF. Multiplied by that ratio, grams of HF goes on the bottom. Mole of HF up top. They gave us the molar mass, so 1 mole is 20.01. Grams cancel. And now you just got to do the second one. Moles of HF on the bottom. Molecules of HF up top. And then Avogadro's number, 1 mole of HF equals 6.022 times 10 to the 23rd. Cancel out moles. And you get your answer. So this one would be 84 divided by 20.01 times 6.022 times 10 to the 23rd. And this one we need 3 sig figs. So 2.53 times 10 to the 24th molecules of HF. And I look at the exponents first. 23 versus 24. This one is a higher number, which means that A was the least overall in the beginning. The first one that we found was the answer. That one was the least amount. So E is out, and A is the winner. So 20 grams of H2O, that has the least number of molecules. All right, guys, this was fun. Thank you so much for tuning in, and thank you for, coming to us with your Chapter 2 OpenStax needs for chemistry. I really enjoyed doing these answers for you guys. Yeah, we're done with Chapter 2. This is awesome. We're moving on to Chapter 3, which I think is, what is it? Light stuff. It's going to be basically formulas. Oh, and naming compounds. That's always fun. All right, guys. Keep up the good work. Keep working hard. I'll see you guys all in Chapter 3. And if you want to subscribe, that'll be fun, right? Thank you so much. I'll see you guys later. Bye-bye.